I love math. Do you? Well, if you do, you should live by the math commandment that states, Thou shalt do unto one side of the equation what thou doest to the other.
Let's go over a question here. Y equals x squared minus 2x plus 1 and y equals negative x squared plus 3x plus 4. If you notice that both of them are set equal to y, this might lend itself to a particular method in solving for systems, such as substitution. I'm going to break this up into two different colors here. So every time I see y, I'm going to write x squared minus 2x plus 1. I see a y variable here on the left side. Instead of writing y there, I'm going to write x squared minus 2x plus 1, what I just highlighted above. I always like to draw a line down my equal sign, kind of crooked. And here's my substitution. So instead of y and y, I'm writing now x squared minus 2x plus 1 there in blue. And this right side here in green is the same. So the first thing we did here so far is substitution. The second thing we're going to do is set it equal to 0. Setting equal to 0 helps us solve for the quadratics. So we're going to move everything to one side. Think, which side do I want to move? Blue over to the green or green to the blue? Well, if I move the green to the blue, I'm going to keep the x squared positive. So again, you're doing the opposite. So if I do one, subtract 4 to the right side, I have to do it to the left side. And now, I got 1 plus 1 is 2x squared minus 5x minus 3 equals negative 1 plus 1 is 0. 3 minus 3 is 0. 4 minus 4 is 0. Now we have it set equal to 0. Multiple methods for solving quadratics now that it's set equal to 0. But before I do that, step number 3, we're going to check the discriminant. Let's go ahead and check the discriminant. The discriminant is b squared minus 4ac. Where do I get this a, b, and c from? Right there. A, b, c. B is negative 5, a value is 2, and the c value is negative 3. We just simplify this and we're going to compare it to 0. Negative 5 times negative 5 is 25. And negative 4 times 2 is 8. 8 times negative 3 is positive 24. 25 plus 24 is 49. And if I compare that to 0, it is greater than. If you remember our previous lesson, when it's greater than 0, then we have two real solutions. What does that mean? There's going to be 2 points of intersection. So, now that we've checked the discriminant and we know, I'm going to go ahead and solve this. Remember, factoring is the easiest, but doesn't always work. My a value is greater than 1, so I'm going to have to do both the x and the box. So a times c is negative 6, b value is negative 5. Whoa. Sorry. Two numbers that multiply to be negative 6, but add to be negative 5. Those are going to be negative 2 and negative 3. those didn't work. So negative 6 times 1 equals negative 6, and negative 6 plus 1 equals negative 5. Those two numbers work. Negative 1, negative 6 and 1, you're going to put an x on those because it splits the middle term here. And then 2x squared, that's going to go into the top left always, and the c value will always go into the bottom right. Alright, greatest common factor here. They have an x in common, this direction, negative 3. Going in this direction, greatest common factor is 2x. And then this direction, if you can't think of anything, it's a positive 1. Go ahead, check your answer. X times 2x is 2x squared. Negative 3 times 2x is negative 6x. X times 1 is 1x, and negative 3 times 1 is negative 3. So here's my binomials. X minus 3 and 2x plus 1 equals 0. Alright, our fourth step here is to solve for x. Now, these two binomials multiplied equal 0, so which means zero product rules that each of these equal to 0. And here I get x equals 3. Remember PEMDAS backwards, you're going to have to subtract before you divide. So subtract 1, divide by 2. X is equal to 1/2. Okay, step number 5, solve for y. Alright, I'm going to take this first one, and you can use either of these quadratic equations, but you're basically going to have to do the problem twice, one with blue, one with green. One with x equals 3, and one with x equals 1/2. So we're going to take 3 here, put it in for the value of x. And then we're just going to simplify. 3 squared is 9. Negative 2 times 3 is negative 6 plus 1. So 9 minus 6 is 3. 3 plus 1 is 4. When x is 3, y is 4. 3, 4. That is one intersection. Let's get the other intersection. Take x equals 1/2. We're going to put it in there for every x value. Y equals 1/2 squared minus 2 times 1/2 plus 1. So 1/2 squared is 1/2 times 1/2, which is 1/4. Let me show it to you. 1/2, 1 times 1/2. Alright, negative 2 is just negative 2 over 1, and when you're multiplying fractions, you can just multiply across. So you're going to get 1/4 this will become negative 2 over 2 plus 1 negative 2 over 2 is just really negative 1, and negative 1 plus 1 is just 0. So you have y equals 1/4. So when I put in 1/2, I get 1/4. 1/2 comma 1/4 is the other point of intersection. And if you did that in decimals to help you understand, 0.50 and 0.25. There's the x-axis, there's the y-axis. Let's go ahead and graph these. There's the origin. Here's that first solution, 3, 4. And the other solution of 1/2, 1/4. So origin. 0.50 and then up 0.25 cents. So that's where I know the graphs are going to intersect. Let's go ahead and just graph this one. Use your graphing calculator, but there's my graph of the purple one, and then let's go ahead and graph the green one. So C value of 4, and A value is -1, so I know it's gonna open down. Fancy word is concave down. Something must be wrong here, but let's go through this. Okay, so you see the intersection there. But it's not going through that other order pair. Let's do some problem solving here. Let's go ahead and put this into our graphing calculator. Y equals, let me clear this out. X minus 2x plus 1 negative xx plus 3x plus 4. Here's what my graph looks like. I think we made a mistake. It should have been -5, -0.5. Let's fix this now. Should have been a -1/2. So that'll become plus. Oops. Sorry about that. Let me get back down here. So that'll become a +1, +1, and 1/4. So that'll become 2 1/4, or 2.5. 2.5, comma, 0.25. That little negative negative 1/2 is negative 0.5, and 2 1/4 is 2.25. Let's fix this messiness. Erase that. There's our intersection. So red, negative 0.5, comma, 2.25, and 3, 4. This is our solution. Alright, let's try D8. Let's solve this quadratic systems. Let me write this problem down below. Give us plenty of space. Y equals 2x squared minus x plus 3. And y equals x squared plus 5x minus 6. So we're going to do the same thing as we did before. We're going to do a substitution first. What does that mean? Every time I see y, I can write 2x squared minus x plus 3. I see y here, and so instead of writing y, we're going to write 2x squared minus x plus 3. Let's do that. Basically this goes right here, right? 2x squared minus x plus 3. And we're going to do the same steps as over here. We're going to set this equal to 0. So let's think ahead. If I move the green to the black on the right side, I'll eventually have a negative 1x. So I'm going to move the black or the right side to the left side. Think ahead, it will save you some pain here. Okay, let's do equal sign. That's the left and the right side. So I'm going to subtract this, subtract, and add. Subtract, subtract, and add. Okay, let's go ahead and simplify now. 2 minus 1 gives us a positive x squared. That's the reason why I went this direction. Negative 1 minus 5 is negative 6x, and 3 plus 6 gives us 9. Over here, remember this is 1 minus 1, which is 0, x squared. 5 minus 5 is also 0, and negative 6 plus 6 is also 0. That's what we wanted here. Okay, now here, you might want to check number 3 here. Let's check our discriminant. Let's go over here, we have some space. Our discriminant is the formula b squared minus 4ac, and we want to know an inequality compared to 0. Okay, so I'm looking over there in blue, so my b value is negative 6. I'm looking right there. My a minus 4 times my a value, which is a 1, and my c value, which is 9. And that's negative 6 times negative 6 is 36. Negative 4 times 1 times 9 is negative 36. So positive 36 minus 36 is 0. So what inequality can we write in there? The answer is that it's equals. What happens if they're equals? That means there is one real solution. Okay, so this should give us an idea. Okay? Okay, so let's continue solving over here. So now we know the discriminant tells us to solve for x. Okay, so let's go for the home run. Let's factor. Again, I'm looking over there on the left side. A times C gives me 9. My B value is -6. Two numbers that multiply are going to be -3 and -3, and we add to be -6. So those are my numbers here. So we just factored, okay, and now we need to solve for x. Okay, how do you solve for x? You're going to set this equal to 0. This purple step is called the ZPR, zero product rule. So you can just do it once because it's the same thing. X equals 3. It's the same thing over here, right? X equals 3. And essentially what that is they call that a double root. It's the same answer, you can just do it twice. So solve for y. How do I get a y now? Look above. You can pick any one of these that you want. I would recommend picking the one that has the smallest. So I'm going to use this one. So I have y equals x squared plus 5x minus 6. Let's do something, and it's the same thing. I use function notation because some students said they still don't get that, which is okay. Let's use function notation. This one's every x value, not too big. Every x value you're going to put in a 3. So we have f3 equals 3 squared plus 5 times 3 plus 6. You can just simplify this. That's 9 plus 15 plus 6. This gives you 24. This gives me 30. Okay. Essentially, this is the x and this is the y. So the order pair we have is 3, 30. And if you did the same thing over here, you would get the same idea. So let's highlight that in a nice obvious color. Then my intersection is 3, 30. And this matches that we have one solution. Okay? Alright, let's go ahead and graph this one. If we were in class again, I would ask you to use a ruler. Alright, let's graph this one. So standard form, you can try to factor this. This is the one we're talking about. Negatives, a times c is -6, b value is 5, and so this would be -2, two numbers that multiply be -6. No, wrong numbers. How about +6, -1? That works. And if you realize that watch those red numbers, just watch them. If you set it equal to 0, you're going to get back to that red number, or the opposite of that red number. A lot of students see. Right, x equals -6, and x equals 1. Okay, so this, I'm trying to graph the one in purple. Let's change that. Purple, purple. Okay, let's just graph this. -6, 2, 3, 4, 5, 6. +1. Okay, it has a y-intercept. The c value is the y-intercept. -6. 2, 4, 6, -6. Okay, and it's opening up, right? A value. So my graph's going to look something like prime intersection, what was our answer? 330, wow. 330 would be, this is 3 on the x, oops, and then 30 is going to be like way up here, okay? This is what our solution is. Let's graph this one. Again, if you factor it really quickly, I'm trying to show you how to graph that by hand. A times c is 6, b value is -1. There are no two numbers that multiply to be 6 and add to be -1. Let me double check and think in my head. -2, -3, negative. You need a positive, right? Two numbers. 6 and 1, 3 and 2. But if I did 3 and 2, then you have to make one of those negative or both negative. Yeah, it's prime. Okay, what does that mean? So my graph is going to go through 3 and it opens up, so it might look something like, I don't know. And then the purple, I don't know, goes through it once. Let's see what our graphing calculator says. Clear. So I have 2x squared minus x minus 3, x squared plus 5x minus 6 graph. Uh-oh. We have, okay, there's one intersection, but it's saying there's two intersections. Let's double check that we put this in correctly. 2x squared minus x plus 3. There's my mistake right here. Okay, there it is. There's our intersection, right? We said it was 3 comma. We said 30, right? And it's not going through 30. Yeah, I had it on the screen. Let's check our math. X plus 6. We said that it was going to be x minus 3, so x is equal to 3. I see my mistake again. It's right here. That should have been a minus 6. Small changes like that, but so 24 minus 6 gives us 18. That means my graph should have gone 318. So that point is not 30, but 3 comma 18, which matches our graph 318. I can't really show you by writing, but at that point. Oh, cool! We can. Look at that. 3. Oh, that's cool. Didn't even know that. See? Oh, yeah. Awesome. See you guys. Hey guys, let's go ahead and solve for D9 on Skills Practice 115. I wrote it below here, and again, we're going to do the substitution method. Let's go ahead and do it. Every time I see y, let's make that figure. Every time I see y, we're going to write x squared minus 4x plus 7. So I see a y variable, and now we can write x squared minus 4x plus 7, and everything over here is going to stay the same. Okay, question. It's not wrong. You can move everything from the right to the left or left to the right. Does not matter. Okay, but you do want to think ahead and consider, well, what would happen if I move the left to the right? I would get a negative a value, which is not easy to factor. So you want to move everything to the left. I'm just doing opposites to go across the equal sign. Opposites. Now, you don't do opposites on this side. Whatever you were on the right side, you do on the left side. Okay, so this gives us 2x squared plus 2x plus 18, and 1 and a negative 1 is 0, negative 6 plus 6 is 0, and negative 11 plus 11 is 0. Okay? Alright, let's go ahead now. So let's review what we've done. We've done the substitution method. We've just set it equal to 0. Let's go ahead and check our discriminant. You have to check the discriminant. B squared minus 4ac. And I'm using right there. Okay, so my b value is 2, my a value is 2, and my c value is 18. So you have 4 and then negative 8, using my calculator, negative 8 times 18 gives me negative 144. And you subtract those, you'll get negative 140. So negative 140 is smaller than 0, which means there is 0 real solutions, or we say no real solutions. What does that mean for us? That means that my graphs will not intersect. Graphs won't cross. Okay? Okay, this is good news. This is good news. Why? You don't have to do solve for x and solve for y. Does that make sense? You only have to solve for an x and y if there's an intersection. This one's telling us they're not going to cross. So let's go ahead and verify that by just graphing. Okay, so the big idea here is we can just stop. We don't have to do steps 4 and 5. Okay, let's graph. Alright. Oh, too thick. There is my, oops. Let's do the blue here. And they already look non-factorable. Okay, what does that tell you? Just means you can't graph it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means, I meant to say that you can't factor to solve for the x-intercepts. And this graph opens down. Okay, I'm not quite sure which side. What you can do is you can plug in points. For example, f of 1. 1 is on the right side over here, okay? I just want to see what happens. I get 1 squared is 1, so the opposite of 1 is negative 1, negative 6 minus 11, so you get negative 7, negative 18. So you have 1 comma negative 18. 1 comma negative 18. What does it tell us? That means the next part of the graph is like way down here, okay? So my graph is doing something like this. Okay, that is the blue graph. Let's try the green graph or something, some kind of color. Let's do purple. Okay, positive 7. 1, 2, 3, 4, 5, 6, 7. Okay, and I know the graph is going to be going through that point. Just put in a 1 there, just like I did in the last problem. It at least tells you, I mean, you just easily copy your calculator. And I'm trying to get an order pair, right? 1 minus 4 plus 7, negative 3 plus 7, that's positive 4. So that is 1 comma 4. That's just another order pair that I can use, right? Right here, okay? What does that tell me? That tells me, alright, at least my graph I know is probably going to be something like this. Okay, what's the big deal? Why we already talked about how there's zero solutions. The graphs are not going to cross, and look, they don't touch each other. Okay, let's punch that into my graphing calculator here. I am not endorsed. I don't get paid for this calculator. So I'm just trying to show you guys helpful things. Press y equals in the top left, press clear, and then x squared. So again, you can do my trick, xx, just goes faster, minus 4x plus 7. Come down here and clear that now. Negative is different than subtraction. Minus 6x minus 11. Okay? And then graph. Look at that. Do those graphs intersect? Nope. See you guys. Hey guys, let's go over D10. We're down below. We're trying to solve this quadratic systems, and we're going to use the substitution method. So let's go ahead and use the substitution method. Let's do that. Okay, what does that tell us? I like to use a highlighter. Every time you see the y, you can write 2x squared plus 4x minus 7. We're going to replace this y with what I just wrote there in red. So instead of writing y, we're going to write 2x squared plus 4x minus 7. And everything in blue here is going to be the same. Okay, I like to draw a line down my equal sign to try to make things look clean. Okay, so now we got to set it equal to 0. How do you set it equal to 0? You can either move everything to the left or move everything to the right. And you have to think strategically. If I move everything to the right side, I'll have a subtracting of minus 2x squared. Let me just show you this. And I don't really want this because I'll have a negative x squared, and then I can't really factor that. Does that make sense? So I'm not going to do that, because Miss Ream just said that would not be wise. So let's not do that. Okay? That was supposed to be red. Okay. So let's move everything to the left side. Left side. Let's do that. So I'm going to subtract 1x squared. I'm going to subtract 2x. And I'm going to subtract 1. 1 minus 1, 0. 2 minus 2, 0. 1 minus 1, 0. Okay? Let me just do this right here. So I get 1x squared, or just x squared. 4 minus 2 is 2, and negative 7 minus 1 is negative 8. I now have something set equal to 0. Okay? What do we do next? Let's test our discriminant. The discriminant, is, this comes from the inside of the radical sign in the quadratic formula. And I'm looking at the A, B's, and C's I'm getting from are from here. So we're just going to substitute that into there. Okay? So my B value is 2. My A value is 1, and my C value is negative 8. So if I simplify this, and we're going to compare this to, we're going to compare this to 0. And 36 is greater than 0. What does that tell me? There's going to be 2 real solutions. 2 real solutions. Okay? That means it's going to cross or intersect 2 intersections. That's what it means. So let's not forget that as we do the rest of this math over here. Okay? So we've done the discriminant. Now we're going to solve for x. How do I solve for x over here? We're going to see if we can factor. So a times c is negative 8. B value is 2. My two numbers that multiply to be 8 are 4 and 2. But I need a negative number, and that's going to have to be negative 2. So 4 times negative 2 is negative 8. So 4 plus negative 2 or 4 minus 2 gives me a positive 2. So that works. Okay. So this is what we have. X plus 4 and x minus 2. Remember, if you were with us in the beginning of the year, we said that this is our way of factoring. Factoring is a hard skill. So go back, type in factoring trinomials into my math channel, and then you're going to see a ton of examples. This is a skill, and that's why I spent so much time on it, guys. Remember, you only have to use the x when a is equal to 1. Okay? Alright, so we need to solve for x here, and all you need to do there is just set each of these equal to 0. This is called the ZPR, zero product rule, which means you set each of these equal to 0. Whatever's on the left side over here, you set it equal to 0. Okay? So if I subtract 4, I get x equals negative 4 as one of my solutions. Use red. And then over here, I add 2, and we get x equals 2. Okay? So what we've done so far is we've just solved for x. We now need to solve for y. How do we do that? Well, you use one of your original formulas, original equations, right there. Okay, I'm going to pick one that has smaller numbers, and I think this one looks good. I'm going to use this one. Okay, so let's use it. I'm going to write that twice. Okay, I can't see it. I always do that. F of x equals x squared plus 2x plus 1. You might be asking, where did I get the f of x? It's the same thing as y, but I just want to show you guys function notation. Why do I want to show you guys function notation? Because you need it, and students struggle with it. So if you see it more, it doesn't become difficult. So if x equals negative 4, that's the number I'm going to put in for every value that's x, negative 4. See that? And then you just do your substitutions. So you have f of negative 4 equals negative 4 squared plus 2 times negative 4 plus 1. And then we just go and simplify. Negative 4 squared is 16. 2 times negative 4. Remember, that's not 2 minus 4 because there's no plus right there. So multiply. And 16 minus 8 is 8 plus 1 equals 9. So this is actually an order pair. That's your x, this is your y. Negative 4, 9 is one of our intersections. Okay? Let's double box it because that's our final answer. Okay? Let's do the same thing over here. I'm now going to put in x equals 2 for every time I see x. Let's do it together. F of 2 equals 2. So every time I put it in parentheses, this is a parentheses, this thing, right there, okay? And then we just go back and simplify. F of 2 equals 2 squared, which is 4. 2 times 2 is 4, plus 1. So you're going to get f of 2 equals 9. So my order pair we're going to get is 2, 9. Okay? So let's transfer those up on our graph. Okay, remember this is our x. X, this is our y. And we're going to put up our points of intersection. 2, 9. Right 2, up 9. 2, 4, 6, 8, 9. And the other one, so we just did this one. And then the green, negative 4, 9. Negative 4, 9. 0, negative 1, negative 2, negative 3, negative 4, right there, okay? So I know my graphs have to go through that point, okay? Let's graph it. This one in red. Let's see if it's factorable. Actually, no, that is the case. A times C is 1, B value is 2. My two numbers are 1 and 1, so that is x plus 1, x plus 1. And that's in factor form, so remember, if you just set it equal to 0, you will get x equals negative 1, which means it's a double root, right? It's the same number there. That basically just means if you go to negative 1, that's what I'm graphing right there. And then a y-intercept of 1, my graph's going to look something like this. Now remember our symmetrical points. It's got to go, sorry, I was saying that because I kind of need to go through that blue point. Does that make sense? Alright. There's my red graph. Let's do a purple graph. I'm going to quickly see if I can factor that. Negative 14 and 4, so I'm thinking 14 and 1, 7 and 2 doesn't, so that means it's not factorable. Okay, if it's not factorable, you're just going to have to use the attributes or plug-in points. So negative 7, there's the origin, 1, 2, 3, 4, 5, 6, 7, there's negative 7, there's my y-intercept. I know that because of that negative 7. I know the graph is going to open up. Remember, that's not my vertex, but we can just kind of expect my graph to kind of go through that point. Now it looks like it's touching all the way, but I'll show you when we use the technology that those are our 2 points of intersection. Okay, so let's go ahead and graph those. Again, here's a plug to the calculator I use. Graph and Calc 83. Found it, liked it, works. Okay. You can also use Desmos. I'm going to use 2x. Okay, some of you guys like the exponent. Fine, use the exponent. Plus 4x. Remember, it's the y-x, not the green x on the screen there. Minus 7. And this one is x squared, plus 2x plus 1. First one is the green, and then the red. Press graph, and there you see it. There's our points of intersection. And you can even do that. Look at that. Boom. 2, 9. Isn't that cool? Boom. Oh, I missed it. Boom. Negative 4, 9. Oh, yeah, I got it. Okay. So 2 of them. 2 points of intersection. Told it by us by the discriminant. See you guys. For D11. And we need to solve this algebraically and then go ahead and prove it graphically. So what I'm going to do is just copy down the problem below. Y equals x squared minus 8x plus 17. And this other equation is y equals negative x squared plus 6x minus 10. Alright, so this is called a system of equations because there's 2 variables, and what we're going to do is we're going to eliminate it. Eliminate one of the variables. Okay, so notice you have both x's and y's, and our goal is to get rid of the y variable. So let's use your highlighter if you have one. Every time we see y, we're going to write x squared minus 8x plus 17. Instead of writing y, we're going to write x squared minus 8x plus 17. That is our substitution. Here, if you notice now, this line has no y variable, and now you can just solve for an x. Well, remember, how do you solve for an x with the power of 2? You're going to have to use solving by quadratics, one of the methods. So, I'm going to draw a line down my equal sign. Now again, you can move this green to the left side. That's what I'm going to do.
Or you can choose to move this red box to the right side. Now if I move the red to the right side, you're going to have negative x squared minus negative x squared, which is negative 2x squared. But I'd rather have it to be positive. So I'm going to add x squared here. I'm moving this one, so I'm going to do the opposite, subtract 6x. And over here, I'm going to be adding the opposite, plus 10. So you notice over here, negative 1 plus 1 gives you 0, 6 minus 6 is 0, 10, negative 10 plus 10 is 0. Okay, so I have a 1 and a 1 here, so this will give us 2x squared minus 14x plus 27. So let's review what we did here. We did the substitution method. And what we need to do next now is basically solve for x. And again, I'm going to solve for x to see if we can do the home run. Is we can see if we can solve this by factoring. And basically what we did there is we're setting this equal to 0. So that is step 3, solve for x. Set equal to 0. Okay, so we have it equal to 0, and now we can see if we can solve this by factoring. A times C is going to be 54. And my B value is going to be negative 14. Let's list out all the factors of 54. 2 times 7, 3, 18, 4, 5, 6, and 9. I think that's all we got. Can I solve any of these problems here by factoring? Does not look like we can. Just double checking the numbers. Okay, what does that mean? We're going to have to solve this by the quadratic formula. Let me double check. That's what we're going to be doing. Well, don't be like me. I made a mistake. And the reason I was saying this is because it's not factorable, but what I was trying to say is I should have done something else. Check the discriminant. What is checking the discriminant? The checking the discriminant is using this formula b squared minus 4ac. So my b value is negative 14 minus 4 times my a value, which is 2, and my c value, which is 27. And I get 196, and negative 4 times 2 is negative 8, and negative 8 times 27 is negative 216. And if you subtract those two numbers, you're going to get a negative 20. Okay, what does that mean for us if it's a negative number? It basically means that the discriminant is less than 0. And when this is less than 0, this basically means you're going to have 0 real solutions. Okay. Now this word zero reals means you're going to have we're going to have some kind of, I'll call it blank imaginary solutions. And we'll talk about imaginary in a second, but the goal is that if you graph this, let's highlight this. You're going to have, the big idea here is you're going to have no intersection. So I should have checked that before even trying to factor. Okay? That's why the factoring over here didn't work. Let's go ahead and graph both of these and you'll see why there is no intersection. Okay, let's have this one in purple. I'm going to see if I can factor it to give myself some x-intercepts and sketch a graph by hand. A times c is 17, and I have negative 8. Two numbers are multiplied by 17. There's just 1 and 17, so this is not factorable. Okay, so it's not going to be a fun one to graph, but let's do it. Here's my x. Oops, here's my y. Okay, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Something up there. Okay? So my graph's going to cross the y-intercept of 17. That's what the c value is. It's your y-intercept. So my graph's going to cross this. I want one point on my graph. I just wanted to kind of know if it's on the left or right side. So if I put in 1, if x is 1, f of 1 equals 1 squared minus 8 times 1. So I'm putting 1 for x, and just see what kind of value do I get. I'm going to get 10. So I get 1 comma 10. Okay, what does this tell me? I got another point. Does that make sense? So my graph is probably going to look something like this. Okay, so let's review what I did. I used my c value to get that value, 17. And to get this order pair, to know the problem went this side on quadrant 1 rather than quadrant 2, I just picked an x equals 1. And I put the x equals 1 into my equation there to get a sketch. And you'll verify that by technology. Alright, let's graph this one. Okay, I was just on a call with a student, and the student was asking, what happens if I multiplied this by negative 1? You can do that. And then here, I want to see if we can factor that. And you realize that 2 numbers that multiply to be 10, but add to be negative 6. I'm only thinking of 5 and 2, which they don't. So this is not fun. And so I have a graph that crosses at negative 10. 2, 4, 6, 8, 10, negative 10. That's my c value, right here. Sorry, the original one is right here. And it's a negative a value, so I know it's going to graph down. You can plug in a point. Let's plug in negative 1. F equals negative 1, because that's my x value that I'm just picking. And you're going to put in for every value of x. I'm putting in the original problem there. We're going to get negative 1 squared, which is 1. So opposite of 1, negative 6 minus 10. And you'll get negative 17. So my graph is negative 1. The graph is something way down here. Right, negative 1, negative 17 is like way down there. But the big idea is are those graphs going to intersect? The answer is no. So let's go ahead and put that into our calculator, and I can show you this by graphing this. You can always use decimals. I'm using this one called Graph in Calc 83. Pad. I'm not sure if it's available for Android, but x, so that's x squared minus 8x plus 17. And then the negative button is down here if I enter. X squared plus 6x minus 10. And then I'm going to press graph. Okay, so here's our graphs. You notice that there's no intersection, so there is no solution for this quadratic systems. See you guys.
Love math. You don't love math? What's wrong?
Alright, let's go over question D12. This is called a systems of quadratic equations. Why is it called a system? You have two equations, and it's quadratics because you see the power of 2 there. And what we basically need to find is our solution. So the directions tell us to solve this algebraically. I wrote them down here. And to solve systems, there's a couple of methods. You can use the addition or subtraction method, which is also called the elimination, or you can do this by graphing it. But graphing is kind of difficult, so we're doing it algebraically, and I'm going to use substitution method. And substitution method works where you're replacing. So every time you see y, I'm going to write 2x squared minus 3x plus 2. I see a y right here, and I'm going to write just what we highlighted. 2, instead of writing y, we're going to write 2x squared minus 3x plus 2. And this side remains the same. What we just did there is the substitution method, and what that does is it eliminates the y variable. So let's go ahead now and solve that. Let's move. I like to have a values that are positive, so I'm going to move this one to this side. I'm going to move this x to this side. Remember, I'm using opposites. Move this positive one, I'm going to have to use minus 1. So this negative 2 plus 2 equals 0. 1 and negative 1 is 0, and 0. So now, if we add those together, we're going to get 4x squared minus 4x plus 1. Okay, we did the substitution method. Now we're going to double check with the discriminant. My formula for the discriminant is b squared minus 4ac. So my b value is negative 4, a value is 4, and my c value is 1. So 16 minus 16. And that equals 0. Now, when you test the discriminant and it's equal to 0, this basically means that it is one solution, which basically means we're going to have one intersection. Well, what is that intersection? Let's do that right now. So, this was equal to 0. The next step we're going to do here is we're going to now solve for x. Solve for x. And I'm going to solve for x over here in the purple one by using the factoring. Let's see if we can factor this. A times c and b. A times c is 4, and my b value is negative 4. Two numbers that multiply before are negative 2 and negative 2. And negative 2 plus negative 2 equals a negative 4. So I'm going to take those and write them here and here always. And I'm going to put an x there. Why? Because negative 2x minus 2x equals a negative 4. So we're basically splitting this term. Let's go ahead and write that. 4x squared, that one goes, the a part always goes in the top left. and bottom right. Alright, let's go ahead and factor this. We're going to have a 2x. 2x. I believe this one's going to be a minus 1 and minus 1. Let's check our answer by multiplying. 2x times 2x equals 4x squared. 2x times negative 1 equals negative 2x. 2x times negative 1 equals negative 2x. And negative 1 times negative 1 equals a positive 4. So now we can write what's on the outside here. 2x minus 1 and 2x minus 1. Okay, we just factored. You can use the zero product rule here. You're going to set each of those equal to 0. And what's the point of doing the same problem twice? We could just do it once. Add 1. Remember that is equal to 0. And then divided by 2. And you get x equals 1/2. Okay, we just solved for x, and now we need to solve for y. Solve for y. Well, how do you do that? You're going to take one of your equations, any of these in the original problem. I'm going to choose this one that has no negative leading coefficient. A value is positive. Why? Because students usually mess up. So let's write that. Y equals 2x squared minus 3x plus 2. Let's transform that to function notation. Okay, don't be scared now. Let's write this as function notation. Did you see every time there's an x, I'm writing parentheses? And x is 1/2. So every time I see an x, I'm writing a 1/2. Now you might be thinking there was no x over there in the original problem. Well, there is. It's called function notation. We say that f of x. And we're just putting in a 1/2. Alright, let's use PEMDAS and solve this now. 2 times 1/2 times 1/2 is 1/4. Make it a fraction, that's negative 3/2 plus 2. So multiply across, you're going to get 2/4 minus 3/2 plus 2. Let's make this equivalent fraction. So you can multiply by this one by 2/2. Make 2 a fraction by putting it over 1, and my common denominator is 4, so I'm going to multiply by 4 over 4. So I have 2/4 minus 6/4 plus 8/4. Why did I do that? If I have a denominator, a common denominator, then I can basically add all of the numerators. So 2 minus 6 is negative 4, and negative 4 plus 8 is 4. So I get 4 over here, which is 1. And what we were doing there was solving for y. Y equals 1. Okay, so my order pair is 1/2, 1. Let's go ahead and graph that. One half, 1. There's my intersection. 1/2, 1. 50 cents on the x, $1 on the y. Okay? Alright, let's go ahead and graph these. Let's graph this one in green. This one does not look factorable. Let's put that to you in green. A times c is 4, b value is negative 3. Two numbers that multiply to be positive 4, and then add to be negative 3. Can I do negative 1? No. 4, negative 1? No, because it multiplies by negative, so there is no numbers. What does that mean? You have a y-intercept of 2, and it has to go through that point. So I think it's going to be something like this. And that's the one here. And great. Let's do another one in a different color. Let's do blue. I don't think that one's going to be factorable either. A times C is negative 2, B value is 1. Two numbers that multiply to negative 2, but add to B a positive 1. Ah, this one might work. That would be negative 2, positive 2, negative 1. Let's multiply to be negative 2, and then add to be a positive 1. So then I get 2x, 1x, 2, I know why. It is a negative. That I don't like this one, but I'll show it to you. Let's find the greatest common factor. This one will be 2x. Let's put this one as negative x. And this will be a negative 1, and this will be a this will work. Negative 1. It's a positive 2x. Let's change this. See what happens. Let's make this one negative. Negative 2x times x is negative 2x. Nope, don't have to be positive. And then let's change that to a positive one. I don't think this one's factorable. Let's double check. 2x squared minus x minus 1. And I'm going to see if I can do it in purple. Negative 2, negative 1. Get negative 2, 1. Negative 2, 1. Okay, inside is 2x squared. And inside is negative 1. 2x, x, 1, negative. Oh, that one worked. Okay, so what did I just do? I factor out a negative 1, and I got negative 1 times x minus 1 and 2x plus 1. You use zero product rule, you set each of these equal to 0, and you will get no solution here. X equals 1 here, and x equals negative 1 half. So if I graph those, 1, negative 1 half, and the graph opens down. And again, it's only supposed to intersect at one point there. Okay, let's use our technology and see what our graph looks like. Take a picture of the original equation. And then let's graph that. Y equals, go up. Oops, I'm not playing Click Computer. 2xx minus 3x plus 2. Here, negative 2xx plus x plus 1. Graph. Something went wrong. Let's double check. Negative 2x negative 3x plus 2, negative 2x plus 1. Okay. Let's double check we graphed it. 2x squared minus 3x. There's the minus sign. Graph. There we are. Okay. And then boom. Half and 1 is our intersection. Sorry guys, it took so long. See you guys.
Mathematics includes the study of quantity, structure, space, and change. Math can be so complex it could be considered strange. So strange equations could be rearranged. Don't even get me started on fractions. To multiply them is going to take a lot of action. But math can be simple. All it takes is practice. Your brain is like a muscle. Make sure it's active.